Mathsit's midterm review. Number 1 says, Angela enjoys swimming and often swims at a steady pace to burn calories. At this pace, Angela can swim 1,700 meters in 40 minutes. So what is the unit rate? What is the unit rate? We're going to have 1,700 divided by 40. And if we do 1,700 divided by 40, we get 42.5 meters per minute. Now, what is the rate unit? That would be meters to minute, right? That is the rate unit. Meters to minute. Number 2, Tiffany is filling her daughter's pool with water from a hose. She can fill the pool at a rate of, that would be 1/10. That needs to have a slash in the middle of it, or a division symbol, which is 1 gallon per 10 seconds. Create at least 3 equivalent ratios that are associated with this rate. Use a double number line to show your work. Okay, well, let's do that. Double number line, 1 gallon. So this is gallons to seconds. 1 to 10. So this would be 2 to 20, 3 to 30, 4 to 40. So there is you 3 more equivalent ratios. 2 to 20, 3 to 30, and 4 to 40. Number 3, Alejandra drove from Michigan to Colorado to visit her friends. The speed limit on the highway is 70 miles per hour. If Alejandra's combined driving time for the trip was 14 hours, how many miles did Alejandra drive? Remember, we have this, the formula is dirt. D equals R times T. The distance is equal to the rate times the time. Here, we have the rate is 70, and we have the time as 14. So to find the distance, combining the driving time for the trip of 14 hours, how many miles, which is the distance, we would say 70 times 14. She would have went 980 miles. Number 4. Kiara, Giovanni, and Ebony are triplets and always argue over who can answer basic math facts the fastest. After completing a few different math facts activities, Kiara, Giovanni, and Ebony recorded their data, which is shown below. Kiara is M equals 5t, where t represents the time in seconds and M represents the number of math facts completed. Giovanni, we just have a table there, 5 to 20, 10 to 40, 15 to 60. Ebony, we have a chart. Well, if you come over here to this next question, it says, what is the math fact completion rate for each student? So, for Kiara's is easy. Kiara's is simply 5 math facts per second. Okay? 5 to 1. For every second, she can do 5 math facts. Now, that's a lot. For Giovanni, we're not for sure. We would have to say, so this is, let's say Kiara is equal. Giovanni's is equal to 5 out of 20. But our problem is we're not in the same order, because Kiara's is 5 math facts per second. So let's flip this to 20 math facts per 5 seconds. Well, what is 20 divided by 5? That would be 4 math facts per 1 second. If you divide by 5, that's what you get. So now Ebony's is going to be, the number of math facts is 12 over 2 seconds. Well, that one's going to be 6 over 1. That's the math facts for each one of them. So who would win the argument? Ebony. So Ebony is 6 to 1, whereas Kiara is 5 to 1, and Giovanni is 4 to 1. That means that they're doing more math facts per second. Okay? Page 2. Ugh. Let's see here. Let me see if I can move this over just for a second. It says the Value Grocery Mart and Market City are both having a sale on the same popular cracker. Michaela is trying to determine which sale is a better deal. Using the given table in the equation, determine which store has the better deal of crackers. Explain your reasoning and remember that you round your answer to the nearest penny. All right. Move this over just a little bit so we can see it here. Okay. Now, we have a table here with the grocery mart, Value Grocery Mart. But we do not know the actual unit rate. For the Market City, we have the unit rate. It's $1.75 per box of crackers. Does everybody see that in the equation? $1.75 per box of crackers. Well, how are we going to figure that out for the grocery mart? We can take any one of those ratios as long as we put the cost, $5 per 3 box of crackers. We can reduce that to the unit rate by dividing. We would say 5 divided by 3, and that is $1.66 or $1.67, I guess if we rounded correctly, per box. Now, you have to think. Just writing down the answers is not going to get it. You have to think here. What's the better rate? The Value Grocery Mart is the better rate because it is the least. It is the cheapest. Right? On the last problem, we wanted the highest, 6 to 1. We wanted the most. Here we want the cheapest. So we would say that the Value Grocery Mart is the better deal. Now, number 6 says, Jill and Erica made 4 gallons of lemonade for their lemonade stand. How many quarts did they make? Does anybody know how many quarts are in a gallon? No. There's 4 quarts in a gallon. So we would take 4 gallons and multiply by 4 because it's a 4 quarts to 1 gallon ratio. So that's going to give us 16 quarts. Now, if they charge $2 a quart, how much money will they make if they sell it all? Well, we'd say 2 times 16, and that would be $32. Oh, that's not right. That is correct, but it's not $16, it's $2. $2 times 16 quarts is $32. 2 parts to that question. Number 7, Franny took a road trip to her grandmother's house. She drove at a constant speed of 60 miles per hour for 2 hours. She took a break and then finished the rest of her trip driving at a constant speed of 50 miles per hour for 2 hours. What was the distance of Franny's trip? So here you have two different formulas. I'm sorry, it's the same formula, but you're going to do it 2 times and add the distances together. Dirt, still working with dirt here. Whoops. I don't know how to spell dirt. So we went at a rate of 60 miles per hour for 2 hours. And then we went 50 miles per hour for 2 hours. Well, what's 60 times 2? That's 120 miles plus 100 miles, because 50 times 2 is 100. So she went 220 miles to her grandmother's house she goes. Okay? 8. A 6th grade math teacher can grade 25 homework assignments in 20 minutes. Is he working at a faster rate or a slower rate than grading 36 homework assignments in 30 minutes? So we have a 25 per 20 minute ratio and a 36 per 30 minute ratio. Now, I know that 5 will go into 25 and 20. And that will go at a 5 per 4 minute. 5, so this person is grading 5 assignments every 4 minutes. Now 6 will go into 36 and 30, and it'll go 6 minutes per 5 minutes. Now, I still don't know which one's a faster rate. How am I going to find which one is the faster rate? I'm going to divide each of those. I'm going to say 5 divided by 4, and that is 1.25. And this will be 1.20, if I can do my math correctly. Yes. And what that tells us is that 25 per 20 is 1.25 or 1.25 of an assignment per minute. The 36 per 30 means that he can grade, or that whoever's grading that one, can do 1.25 assignment, or 1.20 every minute. So which one's the better rate? Well, if you're the teacher, you want to grade more. You want to grade faster, right? So the 20 per 25, or 25 per 20 minutes is the faster rate. Okay? Let's go to page 3. I'm going to have to move this one over again. Now, this one says, here, 100 offices need to be painted. The workers choose between yellow, blue, and beige paint, or beige paint. They decide that 45% of the offices will be painted yellow, 28% will be painted blue, and the remaining will be painted beige. Create a model that shows the percent of offices that will be painted each color. So, the percentage of yellow was 45. The percentage of blues was 28. 45 plus 28 is 73. So 100% minus The 73% is 27%. Now, what is that as a fraction? We can take our percentage and put it over 100 for our fractions. So that would be 45 out of 100 offices, 28 out of 100 offices, and 27 out of 100 offices. Now, how would we write that as a decimal? We can just put a decimal in front of it because we have it out of 100. And know that there should be, you can put a 0 in front, right? 0.27. Now, how are we going to do that? Let's see if I can actually do this with a yellow color here. So I'm going to paint these offices over here on this grid. I'm going to paint 45 of them yellow. So here's yellow. These are all yellow. Now I'm going to paint blue. There's going to be 28 of them. So the easiest way for me to do that is going to be, that's not 20. I didn't do 45 anyway. I did 44, didn't I? I only did 44, not 48. So let me try and fill in that one. Okay. Let's go back to the blue here. And I'm going to say, here's 20. Here's 25. If I've got 28, I only need 3 more in this column. So there's 28. Now for beige, I don't have a real good beige color here, but we'll just call it this brown color. I didn't do that right, did I? $45 plus 28 is 73. 100 minus 73 is 27. But there's way more than 27 over here. Maybe there's one too many boxes. Let me see what's going on right here. There's 1, 2, 3. That's what it was. Mr. Anderson did not do our colors correctly. That should have been for the yellow. I didn't color in 44. I colored in 34 or 35, sorry. So here's 30, 40, and 5. I knew I messed up somewhere. So there's the 45 yellow. Now let's do the blue. Cannot believe Mr. Anderson messed up. Right? There's the 28, and now there's 27 left over for this beige color. Now we're good. Okay? Now let's get back to blue here, and let's do number 10. Show that all the necessary work to support your answer. Convert 3/10 to a fraction, well, and a percent. Well, what did I just say? 3/10. There's my fraction. Now, how am I going to do that as a percent? I'm going to divide 3 divided by 10, and that was 0.3, but then I move my decimal place 2 places, and I get 30%. There you go. So if you have your decimal, all you have to do is move the decimal place. If you have a fraction, you'll divide it and then move your decimal place. Now, convert 3, I think that should be 3/8 as a fraction to a decimal and to a percent. Well, what's 3 divided by 8? 3 divided by 8 is 0.375. Now, I've got my decimal, so now I can move it 2 decimals to the right, I'm sorry. And that would equal 37.5%. You got the decimal, it's the easiest thing, just move it 2 decimal places to the right. Now, 11 says, find 40% of 60 using 2 different strategies. 40% of 60. Well, we know that that's going to be P. Oh, that almost looks like a B. Erase all of that. PW, which means percent of the whole, is equal to the quantity. Well, we have the percent of 60, so we would say 40%. So I'm going to move my decimal. Times 60 is equal to what? 0.4 times 60 is 24. Okay? So that's one way of doing it. Now, it says, one of which must include a pictorial model or a diagram. Well, now we have to do a diagram of that. How are we going to do that? So, one way you could do that, let's do this. If all of this is 60, okay, and I'm going to break that into 40%, I know that fifths, remember this is what you need to know, a fifth is equal to how much? 20%. So if I broke this up into fifths, I would have each one of these would be 20%. So how much is each one of these going to be? Well, each one will be 12, 12, 12, 12, and 12, because 12 times 5 is 60. So this is 20%, this would be 40%, this would be 60%, this would be 80%, and this is 100%. I only need 40, which is just these two, so the total would be 24. 12 plus 12 would be 24. Okay? Now, we may not do that for all of these, but there's how you could do it. Number 12 says 15% of an amount is 30. So we have the percent of some number, we don't know, is 30. Okay? So we don't know the whole. 15% of some whole is 30%. So is this number going to be higher than 30 or less than 30? It's going to be higher than 30. So here's how you do this. When we have PW is equal to Q, we divide by P, and that's the whole is equal to the quantity divided by the percent. So if we do that, 15, let's move that as a decimal, times the whole is equal to 30. Divide by 0.15, divide by 0.15. W is equal, what is 30 divided by 15 hundredths? That is 200. 200 is your whole. So 15% of 200 is 30. Okay? Let's go to page 4. Okay, page 4. Let me move this over again. Okay, here we go. 13 says Jane paid $40 for an item after she received a 20% discount. Jane's friend says that this means that the original price of the item was $48. How do you think Jane's friend arrived at this amount? Well, she added $8 to it, right? So what do you think she came up with the $8? Well, if I think correctly, I'm starting with 40 here. 40 times 20 is equal to what? What is 1/5 of 40? Well, what's 40 divided by 5? 8. So here's your $8. She done the 20% discount off of the amount that she paid and added it to it. But we can't do that. That's not correct. Okay? That would not be correct. We need to say, this is not good. What we would say is, she paid $40, which is the quantity, and we would say 20% of what whole number, or what's the whole that she paid. So all we have to do is divide by 20. So that's the same thing as saying 40 divided by 1/5, right? Because 20% means 1/5, which would be how much? This is where we got to be careful. That's a $200. She paid $40 for an item after she received a 20% discount. Is that correct? Let's think about it. It's 20% of $200 what she paid. No. What did she actually pay? Did she pay 20%? She paid how much? 80%. You have to take your percent here because she got a 20% discount. How much do you normally pay? 100%, right? So you would say 100 minus 20%, you're going to pay 80%. So let's do that now. 0.80 times what number is equal to 40? If we divide by 0.8, the W is equal to $50. Now, does that make more sense? 20% of 50 is how much? $10, right? Well, if I take that off of $50, that's $40. So there's our answer. Good job. 14 says, write one problem using a dollar amount of $420 and a percent of 40%. Provide the solution to your problem. So, here's what you have to determine. Whether the 420 is going to be the whole or 420 is going to be the quantity. Okay? So let's just use it as the whole. So we're going to say that 40% of an item is what? That would be the problem that we write. So all we have to say is 0.4 times 420, and that would be 168. Q would equal, so 40% of 420 is 168. Now 15 says the sale price of an item is 160 after, so this is the quantity, 160 after a 20% discount. What was the original price of the item? Once again, are we paying 20%? No, we're paying 80%. So we need to say 80% of the whole is 160. And if we divide by 80%, that would give you a $200 item is the whole. 16. Angelina receives 2 discounts on a $50 pair of shoes. So that's the whole. The discounts were taken off one after another. If she paid $30 for the shoes, what was the percent of discount for each coupon? Is there only one answer? Remember, there's more than one answer to this question. Okay? I'm going to make it up as I go. So, she paid $50. The original, so the whole is equal to $30. So I'm looking for this percent here. I'm looking for the percent. I'm just going to throw out a percent. I'm going to take the percent, though, off of the... I got that backwards. I apologize. As I was saying that, the whole is $50 and the quantity is 30. So I'm going to say, just starting off, I'm going to say a 10% coupon on $50, which means the 10% would equal what of the $50? Well, that's $5 off, so then I'm left with $45, right? So if I had a 10% discount, I'm left with a pair of shoes for $45. Now, this is where you're going to plug in your formula. I've got a whole of 45, but I need it down to $30. What is my percentage here? Well, to find out, I'm going to divide by 45. So this coupon is going to be 30 divided by 45, which is 67%. So your 2 coupons is going to be one for 10%. Now, is it going to be for 67%? No, it's going to be how much? Because your coupon's going to be for how much? 1/3 or 33%. Right? A 33% coupon. Okay? So there's your 2 coupons. One for 10%.